Hi, I'm Elizabeth with LogicWalk. In this lesson, we'll walk through how the simulator state changes when the computer reads data from the hard drive, focusing on when disk A actively copies data into the computer's memory. For this lesson, we're using the same program as last lesson, just without the display printing instructions. Notice that instruction 6 puts the disk into read mode, and disk cells 2 through 6 already contain the ASCII data we want to load. When we run the program, those values move into disk buffer cells 30 through 34 and memory cells 46 through 49, update to reflect the read status. Let's take a closer look at the process. During the disk copy, the computer remains idle at instruction 8 until the operation completes. At time 5, we see that the computer memory cell 46 contains 5, the data size. Memory cell 47 contains 2, the start disk index. Memory cell 48 is in read mode, and memory cell 49 has a 1, which signals disk A. The hard drive shows that the number copied is 0, and disk cells 2 through 6 hold the ASCII values that will be read. Because the number copied is less than the data size, the hard drive begins copying values from its disk cells into the disk buffer. At time 6, the hard drive copies 108 from disk cell 2 to memory cell 30. The number copied increases to 1, and the computer remains idle while the hard drive finishes its work. From time 7 through time 10, the disk buffer cells fill in order with values from disk cells 3 through 6, and after each copy, the hard drive increments the number copied counter by 1. At this point, the number copied equals the data size, so copying is complete. At time 11, interrupt cell 1 switches to 1, signaling that the disk has finished reading. The computer will respond by first saving its current program counter 8 into memory cell 4, then jumping to instruction 2, as specified in the interrupt table. During this transition, memory cells 46 through 48 remain unchanged. Memory cell 49 turns off, and the hard drive's number copied resets to 0. At time 12, interrupt cell 1 returns to 0, and the computer saves its current instruction 8 in memory cell 4 before executing instruction 2, which is essentially telling the computer to return to instruction 8 and wait idle. Now let's look at a more generalized scenario. At some arbitrary time t, imagine the computer is set up like this. Memory cell 46 holds the total number of values to read, which we'll call size. Memory cell 47 contains the disk starting index, which we'll call begin. Memory cell 48 is in read mode, and memory cell 49 is on, activating the disk. In the hard drive, number copied had some value we'll call count, and disk index number begin plus count has some value which we'll call val. If the count is less than size, then at time t plus 1, the value from disk index cells begin plus count is copied into memory cell 30 plus count. We'll also call that data val, since it's the identical value being moved from the disk into memory. And memory cells 46 through 49 will remain unchanged. The hard drive increases the number copied by 1, and the disk data on the disk cells does not change. Later at some time u, memory cells 46 through 49 hold the same value as time t, and the hard drive still has some value counts in the number copied. If size equals count, essentially when the disk has finished copying all requested data, then at time u plus 1, interrupt cell 1 is set to 1, signaling the computer that the read is complete. The computer's program counter at the moment, which we'll call PC, is saved into memory cell 4. Memory cell 49 resets to 0, and the hard drive's number copied resets to 0. Finally, at time u plus 2, interrupt cell 1 will reset to 0. The program counter jumps to instruction 2, and memory cell 4 still holds PC, so the computer can resume to its previous task. That wraps up this lesson. In our final lesson in Chapter 4, we'll explore the pros and cons of computer memory versus hard drives.